Welcome. Section 3.2 is called measures of variation or dispersion. So quantitative variables are often summarized using numbers to communicate their spread, variation, dispersion, as well as their center. So in the last section, we took a look at measures of center, trying to describe a typical data value. And we considered measures of center like the mean, median, and mode. So what we're going to do in this section is, rather than measures of center, we're going to focus on different ways that you can measure variation in a data set. In particular, we'll look at range, variance, and standard deviation. All right, range we've seen before. It's a really simple calculation. It's just the difference between the highest and lowest data value. But the new thing we see here is variance and standard deviation. So these measures will provide information as to how tightly the data values are clustered around the group mean. So let's see this in action with our first example. So we have a random sample of 3 chocolate chip cookies that's taken from different factories, and the number of chips per cookie is recorded. So we are going to stick with very small sample sizes here just to illustrate the concept of variance and standard deviation. So here's my first factory. So we take a random sample of cookies. The first cookie had 6 chocolate chips, the next one had 8 chocolate chips, and the next one had 10 chocolate chips. So we're going to start with identifying lowercase n, which is our sample size, so 3 cookies. And then in my table here, I'm going to list the data value. So X will represent the number of chips in a cookie. And we'll just list these down the page here. So 6 chocolate chips, 8 chocolate chips, 10 chocolate chips for those 3 cookies. And if we find the sum of those X values, that will be 24. So let's go ahead and calculate the sample mean. So X bar sample mean, you add the data values, which we just did, 24, divide by the number of cookies in our sample 3, and we'll see that that first factory is averaging 8 chips per cookie. I'm just going to squeeze units in here. I'll just write chips. All right, so not every cookie has 8 chips, but that's just our best attempt here to measure a center, a typical cookie. All right, I'll get to range in a second, but let me come over here to factory number 2. So for factory number 2, let's keep track of X, the data. So this seems like a pretty weird factory because they're making chocolate chip cookies, but their first cookie there has 1 chocolate chip, and the second cookie only has 1 chocolate chip. And then this third cookie has 22 chocolate chips. So this factory is all over the place in terms of their production of a consistent cookie product. And if you add those up, though, you will still see that the sum of all those chocolate chips totals 24. So for factory number 2, we also have a sample of 3, and the mean will still be 24 divided by 3. This mean is also 8 chips. So what we're seeing here is that you can have 2 data sets with the same mean, but the data is quite different. And in particular, factory number 2 seems to be showing a lot of cookies that are differing from that mean. And that's what we'd like to measure. How do cookies differ from the group mean? So a general sense of that. So we will get to that in a moment, but I just wanted to go ahead and record the range for each of these data sets. So range is high minus low. So in the first factory, 10 minus 6 is 4. So it's the spread between the highest and lowest value. And then over here at factory number 2, the range would be 22 for the high, minus 1 for the low. So a difference of 21. All right, so rather than using range, though, to describe how the data shows in terms of its variation, we're going to focus on variance and standard deviation. So to illustrate that, I'm going to come back to factory number 1. And what I'm going to do is write the sample mean next to each of these cookies. So we know the mean came out to be 8. And then what I'm going to find out is how much each of these cookies deviates from the mean, from the average cookie, the average of the group. So if you pick up the cookie with 6 chocolate chips and we subtract the group mean of 8, we will get a negative value, so -2 in this case. So the negative is indicating that our cookie with 6 chocolate chips is below average. All right, so what if you pick up this cookie with 8 chocolate chips? Well, the group mean, the group average was 8. So there is no deviation from average for that cookie. So 0 deviation. And then if you get 10 chocolate chips in that cookie, compare it to the group average, that will be a +2. So positive indicating that 10 is above that average. Okay, so if we were to add, so capital sigma there, if we were to add these deviations together that we just found, you'll see the -2 and +2 cancel to 0 plus another 0. So that sum of that column is going to be 0. Now, I'm going to let that factory number 1 go for a second. We'll come back to it. I just want to do those first 3 columns over here for my second factory. All right, so we have X, the data. Let's put the mean, the group mean, next to each of those cookies. And then we're going to look at the deviation of each cookie from the mean. So X is the cookie minus the mean. All right, so here's where we're going to see quite a difference from the first factory. So that first cookie had 1 chocolate chip. So if we subtract 8, that is going to be -7. So 1 chocolate chip is 7 chocolate chips below the average of that group. All right, the next cookie also had 1 chocolate chip. So it is also a difference of -7. 1 chocolate chip is 7 chocolate chips below average. All right, and then this is the cookie I want, 22 chocolate chips. So lots of chocolate there. But let's take that and subtract from the average. And if you subtract that, you'll get a +14. So that cookie had 14 chips over the average. Now, if we add those values, though, -7, -7, that would be -14 and a +14. So that column also comes out to be 0. All right, so here's the idea. We're trying to find a way to find a numerical value to express that. In this case, factory 2 is showing more variation in general here from the mean than factory 1 from its mean. So this column will always add to be 0, so that's not so helpful. So we're going to do a little bit more math here. So instead of just looking at deviation, we're going to look at squared deviation from the mean. So each of these deviations that we got, we're going to take that value and square it. By doing that, a negative times a negative is a positive. So squaring a negative will be positive, and 2 times 2 would be 4. All right, and then 0 squared, of course, is 0. And +2 squared, 2 times 2 is 4. So by squaring, we got rid of the negative. So when we add that column, we're not going to get 0 anymore. We're going to get 4 plus 4 is 8. Okay, so we're not going to worry about how that applies directly to anything right now. I just want to see if we get a bigger number for factory number 2. So let's get this squared deviation. So every x minus x bar value, every deviation that we got, we're going to square it. So in this case, -7 squared. All right, so a negative times a negative is a positive. 7 times 7 is 49. And the next one would also be 49. And then 14 squared. And I just want to take the opportunity on your calculator, just in case you haven't used your square button. If you enter the 14, your x squared button can be used there to square that. And then I'll hit enter. And that is 196. All right, so if we add those squared deviations together in this case, I'm going to get, oops, if I typed it correctly, one more time, too fast. 49 plus 49 plus 196. All right, so that's 294. So all we're looking at right now is we're just seeing that 294 is certainly bigger than 8. So that's telling me I've got more deviation in this second factory. All right, so just a couple more steps then. So what we're going to do is use those values in our calculation for what's called the sample variance. So sample variance, the symbol for it is S squared. And we don't need to square anything again. This is its symbol. So what it is the sum of those squared deviations. And we just did all that work. So that numerator is 8. It gets divided by n, which was 3, the sample size. And the formula is n minus 1. So in this case, that'll be 8 divided by 2, and that gives us 4. All right, that's called the variance. And generally, we're not going to be working with that number. We're going to be working with the standard deviation of the data set. So sample standard deviation is S. So basically, to get rid of this square on the variance, S squared, we're going to take the square root of that value. So S, the standard deviation, is the square root of what we got for the variance. So in this case, that was 4. So the square root of the variance, and that comes out to be 2. Okay, so we just want to compare that to the second factory and see if we're getting larger values in that second factory. All right, so S squared is the variance. The numerator now, instead of 8, is 294. And we're still dividing by 3 minus 1 because 3 cookies in the sample. So now we have 294 divided by 2. So 294 divided by 2, 147. So that's certainly bigger than 4. And then, like I said, usually instead of variance, we'll be working with standard deviation. So this is S, and it's the square root of what we got for the variance. Okay, so on the calculator, above your x squared button, you'll see your square root. So you would hit second and square root. For the older calculators, you might see square root with a parenthesis next to it, which is fine. In either case, whether your screen looks like mine or you have square root and an open parenthesis, type the 147. And now enter. And I would have to tell you what to round to here. I'm just going to go 1 decimal place just to record this. I'm going to say 12.1. All right. So here's kind of what we want to see. How these numbers directly apply to a problem, we're going to see later. Right now, we're just trying to see that the bigger the standard deviation, so factory 2, bigger standard deviation than factory 1, the bigger the standard deviation, the more variation we're seeing in that data set. So if both data sets have the same mean, they both have a mean of 8 chips, the standard deviation of factory number 1, I'm going to put units on. So for standard deviation here, it would be 2 chips versus for factory number 2, the standard deviation is 21 chips. So bigger standard deviation means these cookies are varying as a collection here more from the group mean than they did in factory number 1. All right, and don't worry about having to ever do these calculations again. We're just going through it once you get the idea. And what's coming up is we'll just get these values from a graphing calculator, and we're not going to have to do tables and do all this math. All right, but before we leave these cookies, let me just bring up factory number 3. Now, factory number 3, we picked 3 chocolate chip cookies, and this is a really consistent factory. Every single cookie that they picked here in our sample had 8 chocolate chips. So if you were to add those data values, I'm not going to make a whole new table. I'm just going to write it at the bottom here. If you add the 3/8 together, that will also be 24. So the sample mean here, 24 divided by 3, of course, will be 8. So I say of course because if every data value is 8, then the measure of center would have to be 8. So the mean would have to be 8. All right, so what about standard deviation and range? Let's talk standard deviation. So if I had a table here and every one of these values was an 8 and the mean was an 8, that means everything in the table would be a 0. So when we add things up, we're going to get 0 everywhere. So a standard deviation of 0 always indicates that there is no variation from the mean. So all data values are the same anytime our standard deviation is 0. And then I just threw range as well. Since they're all 8s, high minus low would both be 8. So the range would be 0. So there is no difference between a high and a low number if all the numbers are the same. All right, so that's our introduction to standard deviation for a sample. And then I just have to introduce what would happen if the data was from a population instead of a sample. All right, so what we'll do here is take a look at factory number 2. I'll use that as my example, but let's say that this data represented a population of 3 cookies rather than a sample. So if I had 3 cookies in a lunchbox, so those were all the cookies in the lunchbox, my population of cookies, so capital N versus lowercase n, so population size would be 3. All right, so let's talk about population mean. So we know the symbol from last time is mu for population mean instead of x bar for sample mean, but the math will be the same. So you would still add up your data values. So for factory number 2, 24, and you still divide by n, in this case uppercase n, but it's still 3. I didn't change the data. I'm just changing the fact that it's from a population. So that is still going to be 8. But when we get to variance and standard deviation, we have a new Greek letter, and it is lowercase Greek sigma. So I think I have my Greek alphabet over here. So let's talk sigma. So capital sigma, we've been using that to say find the sum of a set of values. And next to it right there is a lowercase Greek sigma. So lowercase sigma is the symbol for the population standard deviation. So standard deviation is just my abbreviation. That's not the actual symbol. It's going to be a sigma. And we'll be focusing on standard deviation, but we'll just do variance here first. So instead of s squared, population variance is sigma squared. And notice the numerator, the math is still going to be the same. The only difference is instead of seeing an x bar in the formula, it's a mu for the mean. But the column will still end up being 294. So these symbols at the top might be different, but you're still going to get 294 when you add the squared deviations. So that's still 294. But here's the difference. With variance, for a sample, we divided by n minus 1, but the variance for population is just n. There's no minus 1. So now, not only do we have a different symbol, sigma squared instead of s squared, numerically, we're going to get a different answer. So 294 divided by 3 is 98. All right, and then population standard deviation. So standard deviation is always the square root of our variance. So we'll do square root of 98, and then I will have to round that, and I'll go 1 decimal place, so 9.9. All right, so we're going to do a problem here and get the mean and standard deviation from our calculators. And we just have to know correct symbols because the calculator can't read a question and determine if it's a population or a sample. All right, so let's switch gears. I'm done with chocolate chip cookies, and we're going to take a look at a random sample of 6 churros. And we take this sample and we record calories in each churro. So if we've got sample data or any data, the first thing you want to do is get it into a list. So on your calculators, if you go to Stat and Edit and get that data in, so you can pause if you'd like. I've already got that data in, but hopefully you've gotten practice already entering data. You can always check out my TI playlist, the first few videos, to get started there if you need. And then I'm going to write down here the statistics. So statistics describe samples. Sample size would be lowercase n. And I've got 6 values there, 6 churros. And finding the sample mean, the math isn't difficult. We would add and divide by 6, but I want to introduce using one var stats. So what we're going to do is hit our statistics button, stat, and then instead of edit, use your arrow to select calculate. And the first option there is one var stats, so one variable statistics. So you can hit enter and that will be on your home screen. Now I'm just going to do that again because my screen is so busy with other stuff. I'm just clearing my screen. So I'm going to go stat, calculate, one var stats. And your screen should look like this, unless you still have your stat wizards turned on. So just briefly, this was pretty sure this was the very first video in my playlist. So in my class, I work with stat wizards turned off. So your screen looks like this. If you have your stat wizards turned on, there's nothing wrong with that. It's just that not all students have calculators with these wizards. And I like to make sure everybody in class is following my same screen. So I set the calculator up like that. If yours looks like this, I would suggest turning your wizards off if you want to match my calculator exactly. The only difference with wizards on is that it's a kind of a menu driven input. So if you do have this calculator, let's both of us say to the calculator, I'd like to get some information. And that information is going to be based on data that I put in list 1. So if you look at your regular number 1 on your keypad, above it, you'll see L1. So if you hit second 1, you'll see an L1. Same thing on the other version here. So next to list, you want to have it say L1. And then frequency list on this calculator, just leave it blank and hit calculate. For those of us on this calculator, we'll hit enter. All right, and then everybody will come up with the same information, which should match what's in the lecture notes. Okay, and again, check out the calculator video if you want to see all that again. So sample size, we got that. The calculator actually does say n is 6. And then let's do sample mean. So at the top, you're going to see X bar, and you should get 301.5. Oops, sorry, 301.5 calories is the average of those churros. And then it's a sample. So the sample standard deviation symbol is S. And you will see S on your calculator. It has an X next to it. We generally don't write X it's the variable. So you can just say S, and then we're going to round to 1 decimal place. That'll be 21.3. So I'm going to add units for a moment here. So the mean of the churros is 301.5 calories. The standard deviation is 21.3 calories. And coming up, we're going to see how to apply this information. For now, we're just practicing reading the calculator. All right, so what if this was an order of churros that had 6 churros? So it's not a sample. This is the entire order. Otherwise, they would have said it was a sample. So for this population of churros in this order, I kept the values the same, but now we know that we're talking about parameters. So parameters describe populations. So population size So instead of a lowercase n, it's uppercase n, but it's still 6 churros. Population mean, not X bar, that's sample mean. Population mean is mu. Now, mathematically, the value would still be 301.5, whether it's the mean of a sample or the mean of a population. Like we talked about here, the math is the same. So your calculator doesn't have a mu because it doesn't figure out for you the correct symbol. So it's assuming a sample up here, but you read the question, and if it's population data, don't write X bar because it's a mu for population mean, but mathematically, that numerical value will be correct. So 301.5 is correct, just the symbol that you need to change. All right, population standard deviation. It's not S. Standard deviation for a population is sigma. That's kind of what my sigmas look like. Sigma. Now, the formula for that sigma, even going back to variance here, it was a little different than sample variance and standard deviation. So remember there was a difference here. Instead of dividing by n minus 1 for that sample variance, we divided by n for population variance. So what that means is that your value for S, even if it's the same data set, but if it was a population, sigma is not going to be the same. So that's why you're going to see on your calculator, you do have an S and a sigma that's showing. So you need to decide which one it is. Again, the calculator can't read the question, but you can. And you're going to say this was population data. So instead of X bar, I write mu for mean. And then the standard deviation I pick is the sigma value. And that rounded to one place looks like 19.5. All right. So there you have it. So I know I showed you some work in finding these values, but moving forward, you will not have to ever do that again by hand. We will make use of our calculators, one of our stats calculation to get that information for us.